All right, guys, so this lesson is about the next step in factoring, and this one tends to be a little bit faster. So the title of today's notes are Factoring with Differences of Perfect Squares. So we already have the rules that you look for a GCF first, always. If there's 4 terms, then we factor by grouping. If there are 3 terms, then we do this Xbox method so that you get 4 terms so that you could do factor by grouping. But now finally, if there are 2 terms. So first, again, you always check to see if there's a GCF first, and then you move on to differences of perfect squares, which is the title of today. So the first example is just to kind of go through these motions. So first thing you look for is a GCF, and these two actually have a 4 in common, and the second two actually have a 3 in common. But they don't all actually have something in common. So we go through our Xbox technique for this one. So A times C here would be 36, and it has to add up to be negative 12. So you have to find 2 numbers that'll multiply to be positive 36, but add up to be negative 12. And so the hint I gave you was that any 2 numbers that multiply to be positive, but have to add up to be negative, both have to be negative. So there's your first hint. And if you're doing maybe some trial and error here, negative 6 and negative 6 look like they'll work for us. So bring down your first and your last, and each of those minus 6 is go in the middle with an X. So once you have this, you can do your grouping. And out of the first group, you're going to get a 2 and an X, which will leave you with 2x minus 3 if you divide out a 2 and take away an X. Now, the next piece, in order to get a 2x minus 3 in our parenthesis, we want these two to match. You might have to take out a negative 3. If you do that, you get a positive 2x and a minus 3. So we know we're doing it right because everything matches right now. And our final answer will always look like a binomial times a binomial. So that 2x and that minus 3, I usually put here. The 2 that they have in common go here. And then the reason why this is something to talk about today, because this is a kind of a review, is those 2 parentheses are exactly the same. So another way of writing this would be 2x minus 3 squared. We've seen this in the past, and our first move has been to write it twice. Well, now, when you see it twice, we're going to write it like this. So I can go either way. All right, so now moving on to the idea of differences of perfect squares. So very, 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 very important that you know, first off, that it is a difference, meaning minus in the middle. And then perfect squares. S squared is a perfect square because S times S is S squared. 144 is 12 times 12. So what I've done here is listed the first few of the perfect squares. You can see 1 times 1 is 1, then 2 times 2 is 4. So it goes along the left side, and then I know it gets kind of messy there. So, oops, that's not right. Get rid of that, sorry. It kind of goes like this. On the right side, you'll see 8 times 8 is 64, 9 times 9, all the way down, 10 times 10 is 100. So there are some perfect squares for you. Now, the way how this works is really simple. You go straight from the problem to your binomial times a binomial. So there's always 2 spots in a binomial. The first spot in each parenthesis is going to be whatever the square root of the first term is. So what times what is S squared? S. And that goes in the first spot. What times what is 144 is 12, goes in the second spot. And notice I have not put any signs here. When you do a difference of perfect squares, it always turns out that one of them is plus, one of them is minus. And that's it, that's factored. If you wanted to check this, you can quickly double distribute. So you get S squared minus 12S plus 12S, and then minus 144. And you'll see that these two cancel, leaving you with what you started with. All right, so a couple more real quick. This one is a difference, very important, and these two are perfect squares. You can jump straight to your answer, which will be a binomial times a binomial. X times x is x squared, so that goes first. 11 times 11 is 121, and don't forget your signs are one of each, plus or minus. So we'd have A as our answer here. If I'm going too fast, you can definitely rewind and try it again. But here is a kind of an interesting example. A lot of people go and look at these like, oh, 5 times 5 is 25, so I'm going to fill in those. And then, oh, 8 times 8 is 64, and then x times x squared, so that would be 8x, which is all great thinking. And then you're like, oh, the signs are always plus and minus. But this is not right, because this is not a difference, so you can't do it. The only thing that you can think about here is, does it have a GCF? And it does not, so it is actually already done. Nothing you can do to it. So to see it actually done, this is the correct one. It is a difference. I would always start there. And then your 5 times 5 is 25, and 8x times 8x is 64x squared. And now your signs are plus and minus. So we get our answer of D here. All right, and then just to kind of throw a little bit different problem looking here, this one has x's and y's. It is a difference. 4 and x squared are perfect squares. 49 and y squared are perfect squares. So since that is true, 2x times 2x is actually 4x squared. And 7y and 7y is 49 y squared. Signs are plus and minus. So I do believe that the answer is C. And last problem. Definitely looks a little tricky, but follow the same steps. It is difference. 36 is a perfect square, 6 times 6. 169 is harder. It is right here on our list, and that is 13 times 13. X to the 4th would be x squared times x squared, and b to the 6th would be b cubed times b cubed. So we have 2 parentheses. 6 is the easy one, we'll put that last. 13 is 169. X squared is for x to the 4th. And b cubed times b cubed would be b to the 6th. Don't forget your signs are plus and minus. So I believe our answer here is B. Don't forget you can rewind this, watch it again if you need it, but a helpful hint, knowing more of these perfect squares is actually going to help you out when recognizing a difference.